Welcome for another installment, another exciting installment. Notes 10, derivative of trig functions. All right, I'm going to go slow, guys. You guys ready? What graph does this one look like? Yeah, it's a sine. It's going right through the origin. It's a sine graph. I should have put it in terms of, it is in terms of radians, but it's not perfect. I should have put it in terms of the scale, like by pi over 2 or something, but that's fine. All right. So before I even start drawing the derivative of this graph, I want you to observe something. Everywhere that I'm drawing this little, I guess you can call it like a little small tangent segment, that's a slope of 1. Up here, what is that slope? 0. And then notice that little segment there, so that's going to be a slope of -1. So everywhere there's a point of inflection, there's a slope of either 1 or -1. 1, -1. And then anywhere there's a horizontal tangent, I'm putting a horizontal tangent. So all the max and mins, I'm putting little flat horizontal tangents. We haven't done anything crazy. I'm going to say the blue line is my derivative. So if you have colored pencils or a colored pen or maybe just draw darker. So here we go. I am going to plot the derivative value. So we said at this moment right here, I have a horizontal tangent that the slope is 0. I'm going to put a point at 0, at that same x value, but the y value of 0. Have I confused anyone? Right. You see where I have a tangent slope of 1? I'm going to go to 1 at that same x coordinate, and I'm going to put a point at 1. Have I confused anyone? The same x value, but I go to the y value of 1, that's 1. At the same x coordinate where I have a horizontal tangent of 0, I go to the y value of 0. Next one, same x value, the y value, the slope is -1, so -1. Do you guys see what we're doing? So I'm just putting points. All right. Here's how my points look. Are you ready to connect them? Okay. Relax. We're going to start connecting them. Try to draw points of inflection on the x-axis. Where you have maximums, draw like a little cup. What do you call that? Cup, up, backwards cup. And then where you have mins, and look what we just did. Well, this is looking beautiful, guys. Look at that. It almost looks like out of phase. If this were 3D, maybe a helix or something, RNA, DNA. Not quite, but so they don't swirl. But. What does that derivative look like? What does that blue graph look like? Yeah, cosine. Good job. So from that, here's a statement that we can say. We can say d dx of sine x is equal to cosine x. Now, here's the visual. Do you guys want to see? We've actually done it before in the past. Do you guys want to see like I wouldn't call them necessarily a proof, but like, yeah, do you guys want to see the proof? All right. So let f of x equal sine x. If I told you that I wanted f prime of x, here's what you would do. You would go f prime of x is equal to limit as h approaches 0 of sine x plus h minus sine x all over h. Yay or nay? Yeah. And then you remember from your pre-cal day, so side note, that sine a plus b is equal to, do you guys remember? Sine a. So I'm going to replace that sine x plus h with that. So here we go. Do I fit? Let me see. I think I do. Limit as h approaches 0, and I'm going to write sine x cosine h plus cosine h, cosine x sine h minus sine x all over h. I barely fit in there, but I'm in there. I'm going to move this right here. I'm going to move that to the side there, guys. So it's going to look like this. I'm going to write f prime of x equals limit as h approaches 0, and I'm going to write it like sine x cosine h minus sine x. And then I guess I'll write plus cosine x sine h. I haven't done anything crazy. You guys still okay? Okay. I'm going to group these like so. I'm going to group these two. And I'm going to group these two. So here we go. I'm going to start a new statement down here. I'm going to write equals limit as h approaches 0. I'm going to write it as sine x. Well, okay, I'll show both. Sine x cosine h minus sine x all over h plus limit as h approaches 0 cosine x sine h over h. Yeah, we still got enough space. I'm going to factor out a sine x. So here we go. From the first two right here, right? Limit as h approaches 0. This is my sine x factored out. Cosine h minus 1 over h plus limit. And, okay, I'll do it in the next line. As h approaches 0, cosine x sine h over h. So catch up to there. This is a sine x. This cosine h minus 1 over h. This is what I'm going to group together. And I'm just going to move the sine x outside right there. I'm going to do the same thing with the cosine x, guys, because it's not being affected. There's no h on it. It's a cosine of x. So here we go. I'm going to write it like this. I'm going to write sine x limit as h approaches 0 of cosine h minus 1 over h, plus cosine x of limit as h approaches 0 of sine h over h. Hopefully you remember, and it's okay if you don't. The limit as h approaches 0 for cosine h minus 1 over h, all this shebang is going to be approaching what? 0. So I have, and then sine h over h, as h approaches 0, this is going to approach 1. So what I really have is sine x times 0 plus cosine x times 1. And I know if you wrote small enough, you'll be able to fit it, but I can barely fit it right here. So f prime of x is equal to just cosine x. There's my derivative. The derivative of sine x is cosine x. Are you going to do that all the time, every time you want to take the derivative? So just memorize it. I'm not a big fan of memorization, but these know it. And they're easy to know it because you're going to be using them all year long. So what's the derivative of sine x? Cosine x. There it is. d dx of sine x is cosine x. Oh man, I was gonna say take a guess. What do you think the derivative of cosine x is? Yeah, almost. The derivative of cosine x is almost sine x. It is negative sine x. So let me show you a little trick to remember these forever and never ever 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 get them wrong. Do I talk about others? Okay, not yet. When we get to it, I'll talk to you about it. Don't worry, I'm going to tell you today. So the derivative of sine x is cosine x. The derivative of cosine x is negative sine x. Let's practice using these. You guys ready? Look at the first one. Y equals x squared sine x. I got to take a derivative. What rule do I got to use? Well, it's a power rule, but in combination with the product. Underline the x squared, double underline the sine x. So my x squared is the first, the sine x is the second. So I'm just going to do plain old product rule. First, x squared times derivative of the second. What's the derivative of sine x? Cosine x. Plus the second, sine x. I like to use parentheses. Times derivative of the first. What's the derivative of x squared? 2x. Let's make it pretty. Y prime equals x squared cosine x plus 2x sine x. Usually you want to put your product, your variables and all that in front of your trig. But if you wrote sine x times 2x, that's fine. It's just that sometimes people, okay, side note. Sometimes people confuse your argument. So if you would have wrote this, what is that? Like, you know what I mean? Like either you write parentheses that you're multiplying by 2x, or, I mean, because sometimes people think like, is that? Like, you know what I mean? So be careful with that, guys, especially when you have like sine x times 3. So is it 3x, x3, or I guess it's not very common, but still. All right, there it is. Letter B. I'm going to take the derivative of u with respect to x. What rule do I got to use? Quotient. So I'm going to write u prime, or you know what, for fun, let's write du dx. Du dx. So I'm taking the derivative of u with respect to x. Bottom, low d high, 1 minus sine x, times derivative of the top. What's the derivative of cosine x? Negative sine x. Plus or minus? Minus top, cosine x, times derivative of the bottom. The derivative of 1 is 0, but I have a negative sign, so it's going to be a negative cosine x. All over bottom squared. Are we still okay? Oh, because I already have a negative in the front. The derivative of sine x is cosine x, but because I have a minus, I have to keep the minus. Oh, the derivative of 1 is 0. All right, we're done with calculus, guys. That's it. No more calculus. The rest is algebra. So I'm just going to distribute. So du dx, you're done with algebra. So negative sine x times a negative sine x, that's going to be a what? Plus sine squared x. Make sure you put the squared after the n, or use parentheses. We'll talk about that on a little bit as a side note. Cosine x times negative cosine x. Well, it's a negative, but then I have a negative there, so it's going to turn to a. So plus cosine squared x. Either put it in parentheses and put the square on the outside, or put it immediately after the s. Yes. No, go ahead, ask. Are you sure? Okay. All over 1 minus sine x. There should be red flags ringing. There should be some hearts, maybe. I don't know. Valentine hearts, Valentine letters. Did you guys? All right. That's right. The most romantic thing you could ever write to anyone is, I'm sine squared, you're cosine squared, and together we are. And if your boy or girl does not understand that, then dump them and get a new one. Sine squared plus cosine squared equals 1, guys. So now I have negative sine x plus 1 over 1 minus sine x squared. Are we still okay? Notice that the numerator and denominator look like they're almost the same. Matter of fact, they are. Well, one of the factors at least, right? 1 minus sine x, I'm rewriting it. 1 minus sine x, close it squared. So there it is. Rewrote it. I'm going to go ahead and cancel one of them out. If you want to put parentheses there, you can. Bam, bam. So your final answer is 1 over 1 minus sine x. and we're going to talk about some possible dangers. Okay. Don't write this down, just listen so you can really observe. Some possible dangers. You see right here where I have the negative right in that sign X? Sometimes that negative tends to float. Make sure that you do not do that, guys, because now you're telling me that the whole expression is negative. Do you guys see that? So that's a common danger. So that's why most textbooks, not all the time, but most textbooks, if there is a negative, they put it to the backside and they put 1 minus. So you'll see that very common on textbooks because of that reason, because it tends to float. Another thing, so remember when I told you about the squared? So be careful. This is sine squared x. This is not the same thing as sine x squared. The argument is being squared. Chavez, what's an argument? What's inside the parentheses? The argument is being squared. On this one, it's a sine that's being squared. So sine squared x means, giant parenthesis, sine x, close it, squared. Another common mistake that you guys do, you write sine x, and then you go times 3x squared, and you're like, oh, 3x squared times x, that's 3x to the fourth. Sine 3x, or 3x cubed. No, do not ever, as a matter of fact, don't ever do that. That is a sin. You will go to hell. No, guys, I apologize. I want to go to heaven, so I'm going to take that back. But do not do that, for reals. This is an argument. You cannot touch it. It's like saying f of x times 3x squared. You can't. Like, you can't multiply the 3x squared by the x. You just put the 3x squared in the front of the f of x. It's an argument. It's part of the function. You have to have, its sign is never by itself. It has to have something. Sine of x, sine of whatever, sine of theta.
Mr. Chavez?
Yes, ma'am.
Can you please post attendance?
Yes, ma'am. Does that make sense? Okay, give me 30 seconds. Oh, I did. I just didn't push OK. There we go. All right. Did I cover all the possible dangers there? Okay. Here we go. Go to the next page. We are not going to need the whole page, so relax before you're like, OMG, tan x is going to take the whole page. It's not. I just didn't want to print out 3 pages because, okay, yeah. Anyways, so here we go. On the derivative of tan x, I'm going to write d dx because I still haven't taken the derivative. And I'm using a little bit of pre-cal. Tan x is what over what? Sine x over cosine. Good. And now I'm ready to take a derivative. So I haven't taken a derivative yet. That's why I wrote d dx. Equals, I'm not going to write d dx anymore because now I'm actually doing the derivative. What rule do I got to use? Quotient. Bottom, low-D high, bottom, use parentheses, times the derivative of the top. What's the derivative of sine x? Plus or minus? Minus top times derivative of the bottom. What's the derivative of cosine x? All over bottom squared. Perfect. Cosine squared x. You can say cosine x squared. Make sure you put parentheses on it. All right, here we go. Let's simplify this. So I'm going to have cosine squared, and you don't have to write all these steps if you already see it, plus sine squared x all over, and I'm going to go ahead and just go ahead and type the squared after the s like that, over cosine squared x. And then here comes the Valentine's formula again. What's cosine squared plus sine squared? 1. So I have 1 over cosine squared x. And don't leave it like that. I don't want to have a denominator. This is equivalent to secant squared x. So from now on, when someone tells you what's the derivative of tan x, you're going to tell them secant squared x. It's a lot easier to just memorize these, and they're easy to remember. Let's go to the next page, see what we got. Okay, so here are the derivatives that we got to know. And they're easy to remember, guys. Tonight, before you go to sleep, you say these over and over again. You put this in your pillow. No, I'm being serious. Like, Look, tonight I want you to talk to your guardians, and I want you to just give them the paper and go, Mom, Dad, or guardian, adult, or whatever you call them, Tony, and you say, can you help me with this? I just want to make sure that I got it right. And they're going to go, yeah. The derivative of tan x is secant squared x. So say that. Derivative of tan x is secant squared x. Okay. The derivative of secant x, if we would have done the derivative, you know what? Let's derive it. Do you guys want to derive it? No? Okay, I kind of wanted to. Okay, you don't have to write anything down. Just listen. Look, you don't have to write anything down. d dx of secant x. Well, that's the same thing as d dx 1 over cosine x, right? And you would never really do quotient rule for this, but just, you don't have to write this down. Just listen. So I'm going to do quotient rule. So bottom, cosine x times derivative of the top, 0 minus top, 1 times derivative of the bottom, negative sine x, all over bottom squared. So look, cosine x times 0, that zeroes out. Negative times a negative, so I'm going to have, let's see, sine x over cosine squared x. And I'm going to expand this. You don't have to write this down, guys. You don't have to. You have the formula anyways. Sine x over cosine x times 1 over cosine x. Cool? Now check it out. 1 over cosine x is the same thing as secant x. And then sine over cosine x is the same thing as tan x. But I think it comes off the tongue better if you say the secant x before the tan x. So, secant x, tan x. So what's the derivative of secant x? Secant x, tan x. See how it just rose? All right. So here we go. Go back to this. You don't have to write that down. If you didn't write it, it's okay. The derivative of tan x is secant squared. The derivative of secant x is secant x tan x. Chavez, how am I going to memorize these? Guys, it's the same. Look. The derivative of cotangent x. You already used up secant squared, so it has to be cosecant squared. Does that make sense? There's only 2 reciprocals. Well, I guess technically 3 with the tangent and cotangent. But the reciprocal of cosine is secant. The reciprocal of sine is cosecant. So what's the derivative of cotangent? Negative cosecant squared. What's the derivative of cosecant x? Negative cosecant x cotangent x. Look, it's the same. If I already used up secant, then the one I haven't used up is cosecant. I already used up tan. I haven't used up cotangent. Do you guys see how they're the same? Well, kind of. They're almost the same. Now here's the hack. Child, I'm not going to be able to remember what's negative, what's positive, blah, blah, blah. If it starts with a C, it's negative. The derivative of cosine, negative sine. The derivative of cotangent, it starts with a C, negative cosecant squared. The derivative of cosecant x, negative cosecant x cotangent x. So put it in the side somewhere. If it starts with a C, derivative is negative. All right, so try not to look at your notes. Let's see if we already have it memorized. What's the derivative of sine? Cosine x. What's the derivative of cosine? Negative sine x. And I should be saying the argument x as well. What's the derivative of tangent x? Okay, yeah, try not to look up there. What's the derivative of secant x? Perfect. That's the one that has it itself. What's the derivative of cotangent x?
Negative cosecant squared.
Good. What's the derivative of cosecant x?
Negative cosecant x cotangent x.
Okay, tonight before you go to bed, I need you to look at these again and to tell your adults to test you. Can you do that? No, I'm being serious. Or your siblings or whatever, or, call someone and be like, I need you to test me. And, all right. Do you guys have your calculators? Take out your calculators, guys. There's some calculators over there. You can reset them. Second memory 712. Does everyone know how to reset these calculators? Okay, I'm going to show you. Yeah. So all of them are the same. The yellow ones or the new ones are all the same. Push the second button. It should show arrow up key. Push the plus sign. You should see this, memory. Then push 7, because it says reset. Then it says all RAM or defaults, put number 1. And then put number 2 for reset. And you'll get a brand new screen. And that resets everything. Cool? Okay. Here we go. It says, find equations for the lines that are tangent and normal to the graph of f of x equals tan x over x at x equals 2. I need what and what for a tangent?
Oh, that's
I need a point and a slope. So I'm going to get my point by plugging in a 2. So here's my coordinate. 2 comma tan 2 over 2. Let me go ahead and write it in decimal form what that is. 2 comma, and then I'm going to take my calculator. And I'm going to go tan 2 divided by 2. Tan 2 divided by 2. You can use the fraction feature if you want. Negative 1.0925. Negative 1.0925. Negative 1.0925. At least 3 digits after the decimal. More is better. All right, here we go. I have my coordinate. Now I need my slope. Because we can use a calculator, I'm about to show you something. Only use it to check your work. I'm going to tell the calculator to take a derivative of that function at 2. You guys ready? I'm going to go slow. If you have a TI-84, push the math button and scroll down until you see something that says numeric derivative. And mine is number 8. Push enter. It should all of them have the new operating system, so all of them should look like that. Put an X. The X is next to the alpha key, so you don't have to push alpha X. So X like that. And then in here, put tan X, so push tan X, and then close the parenthesis, divided by X. So make it look like that. Then you scroll out. I want that slope at what X value? So put a 2 in there. Enter. There is my slope. 3.4334 if you're truncating. If you're rounding, that last 4 is a 5. So here we go. 3.4234. I like truncated, so I'm going to do that. So I'm going to write f prime of 2 equals 3.4334 truncated. And then I'm going to write my expression. Y minus that negative, so it turns to a plus, 1.0925 equals 3.4334 parenthesis x minus 2. Are we okay? All right. I recommend, guys, as we start getting better and better at this, that you check your work. So I'm going to type this graph into Desmos, and I want to see if this really does look like a tangent. So here we go. I'm going to open up Desmos. Desmos. Oh, thank you, Del. Okay, no problem. No, we're good. Graphing calculator. What was my function? My original? Tan x over... All right. Y equals... Get in the habit of writing y equals or f of x equals. I know it will graph if you just type tan x over x, but tan x, get out of there, divide by x. It'll come back up. All right, here we go. My tangent line, y plus, what did I have? 1.0925 equals 3.4334. X minus 2. And look at that. That 100% looks like a tangent line at x equals 2. Cool or not cool? Perfect. All right, let's see what we got next. What does that y prime prime mean? Second derivative. So let's start first with the first. So I'm going to write y prime. What's the derivative of secant x? Secant x tan x. What rule do I have to use for the second derivative? Product. See, I have something times something. Cool or not cool? I underline the first, I double underline the second. So here we go. First, use parentheses, times derivative of the second. What's the derivative of tan x? Plus the second, tan x, times derivative of the first. What's the derivative of secant x? Secant x tan x. All right, now let's see if we can make it pretty. Y prime prime equals secant x times secant squared x. That's going to be secant what? Secant cubed x. Put the 3 after the c or on the outside of the parentheses. They're both the same. Plus tan x times secant x tan x. So that means that tan is going to turn to a what? Tan squared. So I'm going to write the secant x first. And then tan squared x. If you want to factor out a secant, you could. I'm going to leave it like that. How are we feeling? All right, do we got more? All right. We're done with this notes. Is it okay if we go to notes 10.5? Okay, so let's go to notes 10.5, guys. I have it ready to go. Does everyone have access to notes 10.5? Oh, we're going to do a science problem in a little bit with the ideal gas law. Do you guys know the ideal gas law? Oh, guys, come on. You have 100% learned the ideal gas law. 100%. All right, here we go. That's 10.5, guys. We're going to go slow. We're just practicing. The first 4 is just practice. It wants the derivative. That's what this means, dy dx. Y prime. What's the derivative of 4x to the negative 2? 8 minus 8. That's it. Everyone agree? Okay. Don't freak out. Look at number 2. Do I have to use quotient rule for the x third over 3? You could, but do I have to? No, guys, this is the same as 1/3 x cubed. You can. Look, don't write this down. Just listen. If you wanted to do quotient rule, you can. I'm going to erase this, so don't write this down. Bottom, 3 times root of the top, 3x squared, minus top, x cubed, times root of the bottom, 0, over 3 squared. Yeah, you could do that, but look how much work that is. Minus 1. And then this zeroes out, and then that 3 and that 3 cancel out, or one of those 3s. You still have a 3 squared there. And then I guess I could have canceled both of those 3s, huh? Because that 3 and that 3 cancel out, and look, you just have x squared minus 1. Without that one is that. Do you guys see that? Look how much work that took. And now look at this. I'm going to erase that because that was way too much work for that. I want you guys to see this. Look how awesome this is. I'm going to rewrite this. I'm going to show it right here as 1/3 x cubed. So y prime equals, what's 1/3 times 3? 1. And then I just subtract 1 from that power, x squared, minus, what's the derivative of x? And there it is. We got the same answer. So you don't have, just because it's a fraction, just because it's a quotient, doesn't mean you have to do quotient rule. Child, how do you know? If you have a quotient, but it's a constant, like this one, x over 3 over, x to the third over 3, just turn it into 1/3 x cubed, guys. Or just leave that constant alone. Like, you know what I mean? Okay. I'm going to erase that 1 in front of the x squared because usually you just leave it like that. All right. This one, before you take the derivative, again, you could use quotient rule if you wanted. But I'm just going to rewrite that as x to the negative 1. Laws of exponents. And now we're ready. Y prime equals the derivative. Negative 1 x to the negative 2. Yeah, preferred, you prefer, this is correct. If I just ask for the derivative, you can leave it alone. But preferred, if they give you an exponent that's positive, you want to usually give them back their exponent positive. So y prime equals negative 1 over x squared. Notice that I put the negative right there in the nice in the front. If you wanted to hover that over the 1, that's fine. Cool or not cool? Okay. Laws of exponents again. I'm not taking a derivative yet for number 4. Square root of x is the same thing as x to the 1/2. Here we go. Y prime or dy dx, it doesn't matter. Bring the half to the front. X to the negative 1/2. Usually, if they give you positive exponents, like, well, in this case, square root of x is just square root of x, you usually want to have it like that. So 1 over 2 x to the half, and then x to the half means square root of x. So 1 over 2 square root of x. I'm just showing all the work there. And we finally get to a question that is a real life question.
Oh, I know this.
This is the ideal gas law. The ideal gas law is PV equals nRT. If you Google it, that's what will come out. I hope that you have had some experience with it, guys, because before we graduate high school, there's some laws that you have to have at least some experience, and this is one of them. It's the ideal gas law, PV equals nRT. There's others. There's others with gases, P1 V1 equals P2 V2. So make sure you know those. Some of them, if you really think about it, are borderline common sense. Not quite, but obviously, like if you think about it. Like you have a cylinder, and you put more pressure in there, like think about what's happening. Like, everyone's opened this before, right? And you do that, and then it's like more pressure, because the molecules are all okay. I'll stop because I'm not but you guys know what I mean. Chemistry life, math life, it's all the same, guys. All right, let's see what this says. If gas in the cylinder is maintained at a constant temperature T, the pressure P is related to the volume V by the formula of the form P equals nRT over V minus NB minus AN squared over V squared, in which A, B, N, and R are constants. Find dP/dV. I don't know, maybe you're a graduate student. Maybe you're doing something in the lab, and this is the situation. And you need to find the difference of pressure with respect to volume, the rate of change of pressure with respect to volume. So isn't that cool? You get to do it here. Okay. All right. Let's see what we know. What are constants? So for sure, I'm going to write here constants. And I'm going to write everything that's a constant. Let's see. It's a constant temperature. So T is constant. What else is constant? The pressure P is related to volume B by the formula A, B, N, and R. Those are all the constants. Okay, we're ready. I'm going to write P equals nRT over V minus NB minus AN squared over V squared. And I'm going to do what you guys tell me. I want dP dV. So that means take the derivative of pressure with respect to volume. So for the first rule, so for this one right here that I'm circling in blue, what rule do I got to use? Yeah, quotient. Bottom. No, don't yawn. That's a demerit. This is exciting stuff. How do you yawn? This is so, it's like, I'm like shaking here. Okay, I'll stop. Bottom, V minus NB times derivative of the top. Let's see, nRT is the top, all constants. So the derivative of the top is minus the top times derivative of the bottom. The derivative of V with respect to V is 1. It's like an X. Are we still okay? All over bottom what? Squared. So get up to there. And now I'm going to write that minus is going to go right here. Minus. And I'm going to do this one in green over here. Quotient rule again. Bottom. Time to derivative of the top. AN squared, those are all constants. So that's going to be 0 minus the top, AN squared, times derivative of the bottom. What's the derivative of V squared with respect to V? 2V. Because V is like an X, right? V is like an X. All over bottom squared, so V squared squared. V to the 4th. You can write V to the 4th. I'm going to fix this to make it look prettier. So let's see if we can make this look prettier. So I'm going to go and just write everything in red now. dP/dV equals, that is zeros out. And it looks like I have negative nRT over V minus NB squared. And let's see, what do I have over here? That zeros out, and a negative times a negative is a positive. So plus 2. I'm going to put the, where do I put the V? I'll put it in the front. 2V AN squared over V to the 4th. Oh, look, too, man. But one of the v's cancels out, right, guys? Bam, bam, that's to the third. So my final answer is, I'm going to put the positive term first. 2an squared over v cubed minus nRT over v minus nb squared. And this is probably what you're going to be doing if you're in graduate school in chem and you have to create your own equations. And there it is, like, oh, I need to take a derivative. And there it is, you taking derivative and doing your own thing, being a boss. Cool, right? For your future engineers and future medical doctors. And all right. Don't worry, we're almost done, guys. Question number 6. Y equals 1 plus x minus cosine x. What do they want? Just a derivative? All right. Y prime equals, I should be writing dy dx because they say dy dx, but that's fine. Y prime equals, what's the derivative of x? 1. And the derivative of cosine is a negative, but I already have a negative, so it's going to turn into a plus sine x. Perfect. There it is. Done. Cool or not cool? On the side, you write that 1 over x is equivalent to x to the negative 1. You haven't taken a derivative. That's just to make life easier for you. So y prime equals, bring the negative to the front, x to the negative 2. I'm taking a derivative, guys. That's y prime, right? Plus, you don't have to do product rule for 5 sine x. You just take the derivative of 5 sine x. Plus, what's the derivative of sine? 5 cosine x. Now, I know some of you are going to say, Chav, why didn't you do the product rule? Okay, so slow down. Let's stop real quick. I could have, if I wanted to. Don't write this down. Just listen. I could have, if I wanted to, take the product rule. I could have just gone, I'm just going to show just for this in black. First times derivative of the second plus the second derivative of the first. Derivative of 5 is 0. And look what happens. The sine x times 0 is 0, and you still have just that 5 cosine x. Do you guys see that? So you don't do the product rule on that. It goes all the way back to your notes when we did the power rule. Remember when we did the power rule, it stated to leave the constant alone. And I think it said it like this. I think it said d dx, and it said c, and it said u equals c du dx. I think it said it like that. So then we said, okay, what does that mean? And we did this. Don't write this down, just listen. 5x squared, we said you can leave the 5 alone, and the derivative of x squared is 2x, and then we just did 10x. And then after we got good with this, then we just said, all right, guys, just multiply the 2 times 5. 5 times 2 is 10, and then just subtract 1. And then we stopped doing that. But notice that there's a constant. Do you guys see what I mean? So you can, if you want, do product rule, but it's going to make your life harder because every time you do calculus, you're just going to be doing it the long way. Just do it short. The derivative of 5 sine x, that's a constant. It doesn't have a variable. If it had a variable like an x on it, like 5x, now you must do the product rule. If it's just a constant, 5 times sine x, just take the derivative. Leave the constant alone. Cool or not cool? Okay. Here we go with the next one. So look at the difference, guys. This one, y prime. What's the derivative of a constant? 0. So that 4, leave it alone. That x squared in the front, I am forced to do product rule now. Drag the negative with the x squared, so I'm going to underline that one and double underline that one. If it helps, you can use parentheses like that. If it helps. Here we go. First, negative x squared times derivative of the second. What's the derivative of sine x? Cosine x. Plus or minus? Plus. The product rule is always plus. Plus the second, sine x, times derivative of the first. What's the derivative of negative x squared? Negative 2x. You are done with the calculus. The rest is just algebra, guys. So here we go. Y prime, I'm just making it look pretty. Negative x squared cosine x minus 2x sine x. Done. Cool or not cool? Look at number 9. Should we do quotient rule or should we... Okay, you guys said do quotient rule. Let's do quotient rule. For what? No, what's in the bottom? I would have done that. But let's just so we can see, like, let's just do this with quotient rule. We're at the moment. Bottom, cosine x, times root of the top, 0, minus top, times root of the bottom, negative sine x, all over bottom squared. This cosine x times 0 zeroes out. And the negative times the negative is a positive 4 sine x over cosine squared x, which is correct. We'll leave it like that. I want you to see something. Watch. So one of the juniors said, can't I bring that cosine x up and write that as 4 secant x? I want you to see that two expressions are going to be the same thing. So if I wrote that as 4 secant x, I want you to guys to see this. Y prime equals, what's the root of a secant x? Yeah, secant x tan x. So look, 4 secant x tan x. And then you're going to tell me, Chop, that's not the same as the one in red. And I'm going to tell you, yes, it is. We did it earlier. This can be written as 4 times, I'm going to write the cosine x by itself. 4 times 1 over cosine x times sine x over cosine x. Yes or no? Look at this. 1 over cosine, isn't that secant x? And then sine x over cosine x, isn't that tan x? So there it is, 4 secant x tan x. Do you guys see that? Okay. How much more we got? Cotangent over 1 plus cotangent. Okay, this one we have no choice. This one we must use what? Quotient. We must. This one's no choice, guys. Y prime equals bottom 1 plus cotangent x times the root of the top. Do you remember the derivative of a cotangent? Squared. Yeah, because the derivative of tan is secant squared, so this one has to be negative cosecant squared. Plus or minus? Minus the top, cotangent x, times the root of the bottom, which again is going to be squared. Yeah, same thing, because I have a 1, it's a constant. Right? All over bottom squared. There might be some properties in there. I'm going to leave it alone. We're just practicing on how to take derivatives. Are we okay so far? Okay, this one says no calculator, so let's see if we can do this without a calculator. Find equations for the lines that are tangent and normal to the graph y equals sine x plus 3. I just remembered something, guys. For the last question that we used the calculator, we found the tangent, but I think I also asked for the normal, and we didn't even bother. It's okay. What's up?
The one that we just did. Can we not? Why did we just cross out one of the one?
We can't cross it out because I can't factor out a 1 plus cotangent x on this right-hand side. It's like saying this. I'm going to just make something up. Don't write this down. 3 times 4 plus 5 over 3. You can't cross out those 3's. But if I had a 3 like right here, like that, then you can factor out a 3 and you can cancel it out. That makes sense? Okay. All right. It's a good question. All right. Here we go, guys. I need a tangent slope. I need 2 things. What and what? Point and slope. So here comes pre-cal. It's not even extreme pre-cal, guys. Just baby pre-cal. What is sine of pi? 0. 0 plus 3. There's my point. Pi comma 3. Now I need a slope. Y prime equals, what's the derivative of sine x? Cosine x. So y prime evaluated at pi equals cosine of pi. And cosine of pi is? Negative 1. So here's my tangent line. Y minus 3 equals negative 1 x minus pi. That's your tangent. And we'll check it right now with Desmos. The normal line is the same thing. Y minus 3 equals, but opposite reciprocal for the slope. What's the opposite reciprocal for negative 1? 1. x minus pi. Normal. Let's see if it really does look like a tangent and normal, guys. I'm going to take out Desmos. Let me clear it. What was the equation again? Y equals what? Yeah, sine x plus 3. All right, there it is. And I'm going to have to zoom out. All right, what was my tangent? Y minus 3, negative 1, pi. Yep, that definitely looks like a tangent, guys. It'll come back up right now. Let's do the other one. Y minus 3. Yeah, it does that when it gets really hot. I'm sorry. I can feel the heat coming out of the laptop. Yeah, it's because the computer is doing a lot if you think about it. It's projecting, it's writing, and it's recording. So check it out, guys. There it is. It doesn't look perpendicular because of my grid. It's not a square grid. But let me see if I can fix the grid. There it is. It looks perpendicular now. Cool or not cool? Yeah. All right. Let's see. What do we got next? Okay, here we go, guys. You guys want to see if you guys can do this on your own, a 2-minute head start, or no? Which of the following defines the instantaneous rate of change of the function with respect to t? What does that mean, instantaneous rate of change? The derivative. So find the derivative of this, guys. It looks like it's going to have a lot of baby pre-cal and algebra. I just did the derivative part. So we'll distribute this cosine, sine t, cosine t, minus cosine squared t, and then distribute this sine, minus sine t, cosine t, minus sine squared t, all over sine t minus cosine t squared. Let's see if stuff zeroes out. It does look like there's some stuff that zeroes out. Sine t, cosine t. Factor out a negative. If you factor out a negative in the numerator, you get cosine squared t plus sine squared t. We're still okay? What's cosine squared plus sine squared? 1. So my final answer is negative 1 over sine t minus cosine t squared. Yay or nay? All right, check it out, guys. You guys should be excited. Number 14. You do not have to do that longhand. You just got to recognize. What is number 14 doing? What does this look like to you? Negative sine x. That's it. Why is it negative sine x? I mean, it's because that's perfect. This is the definition of derivative, guys. Write that down. That is the definition of derivative. Definition of derivative. So they want the derivative of cosine x. What's the derivative of cosine x? Negative sine x. So this is why limits were so important, guys. Look at number 15. You can, if you want, do that the long way, or you can recognize that this is the definition of derivative for what function? It's for the square root of x. Hopefully you've done enough of those that you already know it's 1 over 2 square root of x, but if you don't, no big deal, let's do it together. X to the 1/2, that's not a derivative. I'll go to the next line, I'm going to write f prime. F prime of x equals, bring the half down. X, subtract 1 from that half, that's a negative half. So 1 over 2 x to the half. So 1 over 2 square root of x. This is the last page, guys. And that's it. We're done. Just because it looks like we have to use quotient doesn't mean you do have to use quotient. I wanted to bring this example up as a perfect example. I want a tangent line. I need two things. What and what? Point and slope. Here's my point. 1 comma 1 plus 1 is 2. 2 divided by 2 is, so my point is 1, 1. Because I have like a term in the bottom, that means I can rewrite this y equals, so check it out, I'm rewriting it. I can rewrite this as x cubed over 2x plus 1 over 2x. Do you guys see that? And now you just have, let me see, one of those x's cancel out, so I have x squared over 2 plus, I'm going to bring that x up, 1/2 x to the negative 1. I'm going to take a derivative. If you don't like the x squared over 2, rewrite that as 1/2 x squared. I'm going to take my derivative, guys. 1/2 times 2 is 1. And I subtract 1 from that power. So just x minus 1/2 x to the negative 2. So that means x minus 1 over 2x squared. I'm going to plug in a 1. Y prime at 1 equals 1 minus 1/2. So 1/2. What is my tangent line? Y minus 1 equals 1/2 x minus 1. Do you guys want me to do a quotient rule as well or no? What was the equation again? I already forgot it. The original, not before I broke it up. Okay. X cubed plus 1 over 2x. So there's my equation. Oh, it's a fun one. It looks cool. And at 1, 1. So let me put the point 1, 1 so I can see it. I want to know where I'm at. 1, 1. Okay, I'm right there, that blue dot. Give me my tangent. Y minus 1 equals 0.5 x minus 1. Beautiful. Look at that, guys. Beautiful. That definitely looks like a tangent. I know it's been a long day. You guys are getting real tired. Last one. There's the last one, guys. What rule do I gotta use? Quotient. Y prime equals, let's get right into it. Bottom, 2x plus 1 times the root of the top. What's the root of the top? 4. Minus top, 4x minus 3 times the root of the bottom. All over. Perfect. You're done with calculus. The rest is algebra, guys. So let's see if we can do some algebra here. 8x plus 4 minus parenthesis. If you can do it in one step, do it. But if not, no big deal. 8x minus 6 close all over 2x plus 1 squared. I can already see 8x plus 4 minus 8x plus 6 over 2x plus 1 squared. 8x is going to cancel. 6 plus 4 is 10. So I see 10 over 2x plus 1 squared. What letter? How do we feel? All right, we're now beast. Let me pass out today's assignment. Don't worry, it's going to be due tomorrow.